For this lesson, we're going to introduce a concept called linear, specifically asking if something is a linear function or not. So we have an example right here of a table of values. I took these and I graphed them on the board over here, and we can see that they are a function. Every input has exactly one output. The question is this linear? Now the word linear goes back to the graph. I like to take a look at this. Do you notice that these all sit in an exactly straight line? The word linear refers to that. It means that all the points line up exactly in a straight line. So when you're looking at a graph, that's what we're looking for. When we're looking at a table of values, we can see that pattern shows up in the table of values in the fact that each of these has a very well-defined pattern. From 4 to 1, we're subtracting 3, we subtract 3, we subtract 3, subtract 3, and from here to here, each of these is going up by 1, up by 1, up by 1, up by 1. That ends up giving us a nice slope of down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1, which will cause us to have a straight line. So when we see a pattern right here, where the subtraction or addition is exactly the same thing every time, we can trust that it will end up being linear on the graph. So let's take a look at these two tables right here and find the pattern. From 2 to 8, we're adding 6, adding 6, adding 6, adding 6. On this side, we are going up by 1 again, add 1, add 1, add 1, add 1. So we have a pattern that the addition is the exact same thing for every step of the way. So this, yes, is a linear function. If we were to graph this, it would end up being a straight line. If we take a look at this one, you will notice that we add 2, and then this one we add 3, and then we add 4, and then we add 5. And right here we're going up by 2, we're going up by 2, we're going up by 2, and we're going up by 2. So the pattern over here is constant, but here it is not. There is a pattern, and it works off addition, but it's not adding the exact same thing every time, so this one is not a linear function. If we were to graph this, we would see that it begins to increase as we go farther and farther. It gets steeper and steeper. I've got a bunch of examples of graphs right here, so let's take a look at each one of these. Now remember, we're seeing, are they a linear function? This one is a straight line, so yes, it is a function because it passes the vertical line test. So yes, this is a linear function. This one, again, passes the vertical line test, so it is a function, but it is not linear. You can see the curve happening here. So no, this one is not a linear function. It is a function, but it is not linear. Those are two separate questions, and you have to keep that in mind, that it might be a function even though it's not linear. Right here, we can see that we have a straight line here and a straight line here, but it is not a single straight line. There's a bend in the straight line right there. So this one again passes the vertical line test. It is a function, but it is not linear, so no, this one is not a linear function. Right here we have an interesting example. Our graph goes straight up and down, so this is a straight line, so it is linear, but it is not a function. You'll notice that each of these points right here has an input of -3 but separate outputs. So this one is not a function. Even though it's a straight line, it's a straight line, so it's linear, but it is not a function. So no, this one is not a linear function. So we're looking for two things. One, that it's a function, and two, that it's a straight line. Thank you.